All right, everybody, welcome on in. So we'll get started here. Looks like still need more people showing up. Not very many people showing up right away, but usually in the first few minutes we get a bunch of people showing up. So things we need to know, and I'll have to bring this up again because it's more people need to hear it than just the few people that are in each of the streams here. So as of yet, only 15 people have taken the survey. We have 35 people enrolled in the class, almost all of those still participating. So that's less than half. That's not going to work. So I can't release the survey results until we get that number up near 30, over 30, like close, almost everyone in the class has to take that survey. So those of you who have already taken the survey, give yourself a pat on the back. You're the ones sort of doing the things that will lead to success. Good job. If you haven't done the survey yet, that's okay, right? You still can get to success, but you got to jump on it now and get that done. The class is really depending on you. I've had classes where everyone gets on there, takes the survey, and I can release that data within a week. And I've had classes where it takes 2.5, 3 weeks before I can release that data because we just aren't getting people to take the survey. I cannot release the survey with 15 data points. It's not going to work, right? You won't really be able to do the type of work that you're trying to do. Okay, so if you haven't done it yet, just take the survey right now while I'm teaching class. Just sort of do it off to the side while I'm going over this stuff. The stuff today is not terribly complicated. It's important, and you need to understand it. But you could probably also take a survey while I'm doing it if you wanted. So we need that done. So any of you in here, maybe people thought because of the holiday we weren't having class. I wonder why there's nobody showing up to class today. But this is not a holiday that is generally celebrated in California, so we have class still today. Okay. Always got to check that. Sometimes people make assumptions about holidays, and I've seen it hurt people both ways, right? Where they show up to class when there isn't class because it's a holiday, and then people show up or people assume it's a holiday and they don't come. For some reason, there was a lot more sort of people were talking about Columbus Day a lot more, which is now in many places known as Indigenous Peoples Day, but it is not a holiday that we get off for school. So always just double check. Go to the VC webpage, and right from the front page, you can check the academic calendar, right? Like I showed you on the first day of class, but I'll show you again. You go up here. You go to, so what is it? Under academic programs, under here, there's a choice for academic calendar. So if you see it, I'll show you academic programs, academic calendar, click that. Then you just go down to the calendar and click it. And there you go. And you can see today is definitely not a holiday. So don't make assumptions like that, end up setting you behind. Okay, and I know I'm talking to at the moment at least, I'm talking to the people who showed up. But for those of you watching this later, you will always double check, right? And maybe that's not the reason we have such low attendance today, but I would sort of guess that's why we do. Okay, always a good idea. Just as a student, just print this out, have it handy, or save it to your desktop or something so you can conveniently check it when you need to know, is there class today? You can always just go look. Okay, with that said, again, I will have to sort of bring it up later about the survey because all of you who want to actually get started on your survey, you're going to be waiting and waiting until I can release that data. I can't release the data until people have taken the survey. Okay, so getting into some pretty important stuff here. It's not, here's what I'll say. It's not super complicated, but it does have some nuances that you kind of have to understand. So don't go into this just going, yeah, I know the formula for the mean, right? It's really about understanding things like, well, what's the difference between the mean and the median? When should I use the mean? When should I use the median? Are there times when I should use both the mean and the median? The answer to that question is yes. There are times when bringing up the mean and the median can help you understand your data. There's times when one is a good measure and the other one's not a good measure. So, how do you know all this? It's not just a matter of having the formula memorized and being able to, when StatCrunch says calculate the mean, you go, okay, I can press the button to open this in StatCrunch, and then I can press the button that says whatever it says, summary stats or whatever, and then I copy the mean over to my homework. You need to understand it at a better level than that, especially if you're going to be talking about this stuff in your survey in a way that is, when you're having a discussion about in your project, it's very obvious if a person really knows what they're talking about or if they've just kind of memorized some things and are stating them. So okay, so what we're going to start off with is measures of central tendency, okay? So remember, I'm using a different book because the book we're using is really great for the online course, but there's a little bit more convenient book that I can use for visualizations. It's Triola. I just looked up Triola PDF and found an older version that's available online that I'm going from. So that I just use that. It's a better visualization tool when I'm trying to show definitions and stuff like that. But it's the same. It's not like it matters which book we use when you want to know the mean. The mean is the same no matter what textbook you use. There's a few things that are taught slightly differently, like percentiles and quartiles and stuff like that. But the differences between those are very small, right? Sort of insignificant. So even though we're looking in a different book here, it's fine. It's the same definitions we're looking at. So the definition, a measure of center, or what we called a moment ago central tendency, is a value at the center or middle of the data set. Because there's really two things you want to know when you're looking at a data set. You want to know basically what is the shape of your data, and you want to know where it's located. Okay, so talking about the center gives us an idea of where it's located. Where is our data located, right? Where is it that this data lives? So we try to pin down the middle or the center in some kind of a meaningful way. Now, then we run into trouble, right? So this is where statistics starts to get a little different than mathematics, in that in mathematics, generally when we have a procedure, it's a well-defined procedure. There's one thing you're going to do, right? If I give you an equation and say solve this equation, then you either end up with the right answer or the wrong answer, okay? In statistics, there's more than one way to measure the center, because data sets they're all very different from each other. Every data set you ever deal with is going to be different than every data set that you've dealt with previously. And so what we want to do is have more than one tool that we can use to describe that data, right? Because there's sometimes where what you're doing, the mean really is the best way to measure the center. And then there's other times where the median is the best way to measure the center. There's occasionally times where the other measures of center come up and can be useful, but 99% of the time, you're going to want to be talking, when you have a data set, you want to either be discussing the mean or you want to be discussing the median. And as I mentioned a little while ago, there are times when you want both. You want to actually discuss the mean and the median, because if the mean and the median are the same, or roughly the same, or the mean and the median are very different from each other, then that gives you information. That gives you some insight into your set, which you can use to discuss things and sort of explore and go, what can I learn from this, right? And that might seem weird, like, well, if they're both measuring the center, then how can they be? Then how could they come up differently, right? Well, you hear this all the time, like when things happen in everyday life, especially as you get better with science and mathematics, you start to catch this kind of stuff. People will come up, for example, I think maybe we talked about this earlier, like, on the sports channels, 24-hour sports channels now, they need 24 hours worth of stuff to talk about. So a lot of times they just talk about stuff that doesn't even make any sense. You'll hear them talk about things like, who's the best player? Who's the best player in the league? Well, the reason they can fill up so much airtime with those kinds of discussions is because they're not actually saying anything like meaningful or productive. They're actually having what is a very messy, sloppy conversation because they're trying to drag things out because they have to fill a bunch of airspace. But it's just a very messy conversation because they're not actually pinning down what it is they're talking about. So you take, for instance, baseball's kind of we're not at the end, but slowly coming to an end here. Okay, so who was the best player this season? Okay, well, what does the best player mean? Right? What could it mean to be the best player? There's no true definition of what the best player is, right? Is it the pitcher who won the most games? Is it the pitcher who had the best winning percentage? Is it the pitcher with the most strikeouts? Is it the player who hit the most home runs? Is it the player with the best batting average? Is it the player with the most stolen bases? Is it a player who maybe they led in 2 of those categories, and so maybe they get extra consideration? Like, what are you talking about when you say what is the best player? It's actually a very silly question, right? But that's what sort of makes it entertaining, because they can just make up stuff the whole time, because that question doesn't actually mean anything. What they should be doing is pinning down what are they talking about. Who's the best hitter? Okay, well, how are we going to judge hitters? Home runs, on-base percentage, slugging average. There's all these different ways to measure things. Pin down what you're talking about. So that's what happens with sets. We can measure the center, but there are different ways of measuring the center, right? What exactly are we talking about? You get this too when people talk about, like, well, you'll have 2 objects and someone will say, well, which one's bigger? Well, what do you mean by bigger? Do you mean volume? Because a lot of times people don't mean volume. The one that's heavier. Okay, well, then you're defining which one is heavier, not really which one's bigger. Which one takes up more volume? Which one has more surface area? Depends what you're doing. If you're painting something, then what you really care about is surface area, right? If you're filling something with water, then what you care about is volume. So the question which is biggest doesn't really make a lot of sense until you actually define your terms. So in statistics, we have a few different ways of measuring center, a few different ways of measuring the shape or the spread of the data. So they're all legitimate. They're all perfectly good. In fact, they get used in different ways at different times. Just like if you're talking about who's the best pitcher and you decide, well, this individual had won the most games, okay, but this other pitcher had the best winning percentage. Okay, so you can kind of say, well, depending on how we measure, then we get 2 different candidates for the best pitcher, right? And then you can have like a sort of more of a meaningful conversation rather than just, watching celebrities go on and on about words that don't actually mean stuff. It's the same thing here, right? So the first one is the one that most of you are familiar with. It's the one that many of you have, asked your teachers about when an exam comes out. What is the average, right? So in statistics, we don't use the word average because technically the word average just means measure of center. But in statistics, we have multiple measures of center. So it's one of those things where someone might say the average and they think that you understand they mean the mean, but the person listening to you will say, well, which one are you talking about, right? So it's confusing. It's a sloppy way of discussing things. It's not a very good way of communicating. So we don't generally say the average. And you'll hear me accidentally say it sometimes during class. It's not a good thing to discuss. So we don't want to use the word average. We want to use the word mean, because if I say the word mean, then no one's confused about what I'm talking about, right? They go, oh, well, yeah, the book defines the mean, and the videos and Canvas define the mean, so I know exactly what he's talking about. Okay, so that's the mean, what most people think of as the average. And I'll tell you, people use the mean because it's the only measure of center that they know. It's like the only one they've ever heard of. And yet most, well, I gotta be careful. I don't know about most of the time. A lot of the time, it's not the right one to use. Okay, so, and I'll give you some examples when we get to it. But one quick example that you can imagine: people always, when I give out tests, people want to know what's the average, and they're really asking what is the mean. The mean is not a good way for measuring test scores, because usually in a class, a full class of people taking the test, there's at least 2, 3 people. Sometimes it's 1, sometimes it's 3 people that did really bad, like 0 bad, or they showed up. They haven't done a single thing in the class, but they showed up just sort of hoping that they were going to walk out with an A or something, and they end up getting like a 3 on the test or something. They like remembered I think I saw this one problem in grade school, and they kind of remember a little bit and they get a couple points, but they get like a 2 or 3 on it. Well, those are outliers, right? Because most people are scoring up in the 60s, 70s, 80s, 90s, up around in there, right? But a handful of threes is going to pull that mean way down, right? It's going to pull it way down. So usually when people ask about the mean, what they're wondering is, am I in the top half or the bottom half, right? Because they're wondering where the middle is, which is actually the median. You want to be asking what's the median score, not what the mean is, because if you have a few scores pulling everything down, that might pull down the mean enough that like 80% of the class or more is above the mean. So you're thinking, oh, I'm in the top 50%, when really you're in the top like 85%. That's not as good, right? So the way you calculate the mean, like StatCrunch will do it for you, but it's a pretty easy calculation. I'm sure almost all of you know it already. You add up the scores, you divide by the number of scores. So it's as simple as that. If you have 10 data points, you add up the 10 data points, then you divide by 10. If you have 15 data points, you add up the 15 data points, divide by 15. Now, obviously, that only works for quantitative data, right? We can't do that to eye color. We can't add up 10 eye colors and then divide by 10. That doesn't make any sense, right? So you would not apply the mean to categorical data or qualitative data. You would apply it to quantitative data, quantities, numbers. And basically, it's a no-brainer. Anytime you have quantitative data, you should be calculating the mean and the median every single time. That doesn't mean you're going to use the mean and the median in your discussion, but you should look at them, right? Because a lot of times it's going to inform your next steps that you take looking at your data and going, okay, before I start calculating the shape of my data, at least I can kind of know what these two measures of center are, okay? So let's see. The mean is helpful because it uses every piece of data. Every piece of data gets used in the calculation, right? So that's one thing to remember about the mean, because you're adding up all the data values. Every piece of data gets used. That's not the case with all measures that we use in statistics. So that is one to keep in mind about the mean. One of the main disadvantages of the mean, I just gave you an example of. One single outlier can throw off the whole thing. It can move that center so far in one direction that it gives a misrepresentation of what the center really is. So that's a problem, right? I just gave the example, and that's like real world examples I just gave you. Students in class asking about the mean and then feeling like they did much better because they're like, wow, I beat a lot of people in the class, when really they might be right in the middle. But because they asked about the mean and the mean was pulled down by like 3 really low test scores, every student in the class feels like they're in the top, right? Oh, I'm up in the like top 20%, when they're probably not, but they're misinterpreting the data from the mean. Let's do another example. Here's one. For any of you who have ever looked at homes, when you look at home prices, they never talk about the mean. They talk about the median. And I know I haven't talked about the median yet, but we'll come back to this example in just a minute. So this column is going to be house price in thousands. So when I write 500, that really means 500,000, right? So, you know, home prices, Southern California, things are expensive. Let's go with this. Okay, so this is something that definitely can, let's see, did I go, I think I went too many. We want, if it's in thousands, I want 1750 there. That's what I want. Otherwise, it'd be crazy extreme. So this is a thing that happens in lots of places, but this can definitely happen in different neighborhoods, right? You know, some neighborhoods, like the newer neighborhoods, when they're building brand new neighborhoods now, it's just like a factory. Every house looks exactly the same. It's like almost the exact same color, exact same shape. It's like they just have a stamp and they're just stamping the ground, and all the houses kind of look the same. But a lot of neighborhoods, especially if they're a little bit older, you go into these neighborhoods as if they're like more custom homes where it wasn't just someone came in and built a million, you know, cubes and they all look identical. you get a variety of houses. So you get some smaller houses, some big houses, some newer houses, some that have been totally renovated, some houses with views, right? Those of you who live in neighborhoods that are up on the hills, you'll know, I don't have a view from my neighborhood, but there are people that live near me that have awesome views of the city, but I don't have one, right? Well, that view can get you, more money. Your house is worth more. When we were looking at houses, the view, if your house had a good view, seemed like you got about an extra $100,000 on the price of your house. I don't know what houses are going for now, but things like that can affect it. There's a couple houses in my neighborhood that are just monstrously huge. I can't even imagine. I've never been in them. They're absolutely huge. So this kind of stuff happens where you have a bunch of houses about the same price, and then you'll have like maybe one that's just gigantic. Okay. Well, you're looking for a house, and you're looking at which neighborhoods should I go look at houses? Because there's so many houses for sale at any given time, and you're trying to wonder which are worth my time to go look at? Should I go to this neighborhood? So you might wonder, well, what's the mean price of homes in this neighborhood? You could say, well, my price range is around 600,000, 625, somewhere around in there, maybe up to 650,000. I wonder if I should go look in this neighborhood for houses. So you ask if you have someone helping you or whatever, if you're on a website, and you look up, well, what's the mean of the sale price for homes in this neighborhood? Well, so let's look what this will do. So if I go here, summary stats, columns, go to that one, compute. So the mean in this neighborhood is $717,000 for a home. And you go, oh man, I was saying that my price kind of topped out around 625, but it looks like the mean house is 717. I think this house is above what I can afford to spend, or this neighborhood is above what I can afford to spend. So I'm not going to go there. I'm going to look elsewhere. But what happened, actually, of the 7 homes for sale in this neighborhood, I could have afforded 6 of them, right? Except this one house here that's super expensive, right, threw off the mean. So this one outlier it pulled the mean so far in one direction that it now gave me the impression that I couldn't afford this neighborhood, right? So, I can't go there now. Right, in this hypothetical situation we're talking about. So then I skip it, but there's a whole bunch of houses there that maybe I would have bought. I might have picked one of these and gone, no, that's nice. I like that. I'm gonna move in here. But the mean gave me the wrong idea. So I haven't described the median yet, but look at the median over here, 550. That's why home prices in neighborhoods are usually given by the median. It's a better tool for homes in general for exactly this case. If I look at the median and go, oh, I could afford that. In fact, maybe I could afford one of the better homes in this neighborhood. I can go a little higher than 550. So yeah, maybe I'll look at those other homes. So then I go to I tell my realtor, if someone's helping me, oh yeah, can you make reservations at some homes for some viewings in this neighborhood over here? I'm kind of interested in that neighborhood. And then I go check it out. So see how the mean and median are not close to each other? If you're looking for houses, if you're looking to spend $550,000 or you're looking to spend $717,000, you're going to different neighborhoods in general, right? Those are going to be different from each other. So depending on which measure of center you use is going to lead you to make different conclusions. That's why you always want to look at both of those, right? Sometimes the mean is a good measure. Sometimes the median's a good measure. Sometimes both of them are informative together. So I look at these and go, oh, okay, well, when I looked at the mean, I didn't think I should go to this neighborhood, but the median makes me think I should, right? So then I would go there. Okay, so let's return back to that in a moment. So, and when you're looking in things online, this symbol, for those of you who don't know, that's capital sigma. It's just a Greek letter. In mathematics, that means add some things up. That's all it means. People overcomplicate it and get scared by it. It just means add up some stuff. So the mean is where you add up some stuff. You add up all your data values. That's all that means. Take all your data X values. We use X for any data value. So any value that's in your data set, add it up. And remember, lowercase n is always the size of our data set. So you add up all the data points, divide by n. So it looks like when you first look at that formula, people are like, what? What is that what is that symbol? I don't even know what that means. It just means add up your points, divide by the number of points, right? Nothing too complicated. Right. Okay, median. The median of all data sets is the measure of center that is the middle value when the original data values are arranged in order of increasing or decreasing magnitude. Okay, so let's go back to our StatCrunch over here. And let's see, I haven't done this in a while. Let's see if I can find it. Where was it? Arrange. Sort, maybe. We want to sort this one column. Oops, sorry, I'm putting it behind my head. Sort by ascending. So this is, oops. Sort by. Okay, so you might see they're in a different order now. What I did is I just had StatCrunch sort the order for me. So see how they weren't in order from least to greatest before? I don't think they were. I think I had a couple of these top values mixed around. But I just had StatCrunch sort it for me. Right, it went through and sorted it. So from least to greatest. So our definition says the median of the data set is the measure of center that is the middle value when the original data values are arranged of increasing or decreasing. It doesn't matter because the middle is going to be the same if it's increasing or decreasing, but you have them in order. If you take the middle of your list when it's unordered, then you're still essentially just picking a random value. So you have to sort it into least or greatest. Now, most of the time you're just going to get the median from your stat summary. So you're not actually going to be calculating it, but you should understand how to calculate it. So I put my data set from least to greatest. The one in the middle, let's see, if we have 7 points, so 1, 2, 3, 4. So there's 3 before this value, and there's 3 after this value. So my median should be 550, this value right there. And I think that's what we got a second ago, right? Yep, my median is 550. So you're literally picking the value in the middle, right? So we're starting to see that in some ways, like, oh, that median value actually makes a lot of sense. You're literally picking the data value in the middle, whereas the mean is a you know, it's not a very complicated formula, but it is more complicated. And sometimes you go, actually the median is a little more intuitive. We all grow up learning, you know, quote unquote average, which is what we mean by the mean, and so it makes sense to us. But actually, when you think about the median, you're almost like, that actually makes more sense. Maybe that's the better one to go with. And again, it's all context. It depends on the particular problem that you're doing. There is no right or wrong. So there's no golden rule that I can give you that says, in this case, use the mean. In this case, use the median. In this case, use both. Like, it doesn't work that way. You have to get in there, get your hands dirty, play around with the mean and median, and then decide which one you're going to use as part of your, you know, when you're making your case. You're trying to make your argument for the data that you're trying to understand. Okay? Now, question arises, well, what if we have an even number of points in our median or in our data set? Then how do I choose the one in the middle? Right? When there's an odd number, it's easy to choose the middle. There's literally one in the middle because, like, for 7, the 4th position has 3 data values before it and 3 data values after it. Well, at 8 data points, you've got 4 in front, 4 in back. What's the middle value? Well, what you end up doing in that case, let's see if I think they probably walk us through it, right? Basically what you do, so here's an example. We've got 1, 2, 3, 4, 5, 6 data points, and we want to find the median. So see how there is no middle data value? There's kind of 2 in the middle. So what we do is we take the mean of the middle 2 values. So you take these 2 in the middle, 23 and 24. We find the mean to get 23.5, and that's considered the median in that case. So for an odd number of values, you just take that middle data value. For an even number, you take the 2 in the middle and you take the mean of it. But see how this is still pretty close? I mean, we could argue, yeah, 23.5 is still a pretty good measure for the center because, look, it's right between these two in the middle. So it's still a pretty good argument when we do that. And then here they just say, never use the term average when referring to measure of center. The word average is often used to mean mean, but it's sometimes used for other measures of center. So to avoid the confusion, we just don't do it. Okay. I won't talk too much about the mode. It doesn't get used a ton. It sometimes gets used, but it's not like part of the big ones like the mean and median. The mode is just the thing that was picked the most number of times. Okay, so if we asked everyone in the class what their age was, then if the most number of people were 19, that would be the mode. It's just telling us the most sort of, quote unquote popular, the option that got picked the most. You could have a bimodal situation if there was a tie. Maybe we have a whole bunch of 18-year-olds and a whole bunch of 19-year-olds. Well, then it could be what we call bimodal. There's two modes. And you can have more modes than that too, but we won't run into it too much for the kind of stuff we're doing in this class. Okay, but the mode just means the thing that happened the most. The mid-range gets used even less. It's affected by all sorts of stuff. So the mid-range, you take the top value, the bottom value, you take the mean of those, but you're almost never going to see that. Let me go back. So strengths and weaknesses of the median. The median does not change by large amounts when we include some outliers. So the mean we saw was very affected by outliers. The median is much less affected by outliers, right? That was the real estate situation we looked at. Like the mean was really giving us a price range that didn't fit any of the houses in that neighborhood, right? When we looked at it, if you're looking to spend $750,000 on a house, well, then most of these houses are probably a little low for you, and this house is too expensive. So if you went to the house because it had because the mean said 717,000 and you're thinking, well, that's my price range. And you go look and you go, actually, these houses are a little smaller and a little less than I was thinking of. And this one's too expensive. You just wasted your, a couple hours going out to this neighborhood and not finding what you wanted. Where if you went to a neighborhood where the median, we already talked about looking at the median piece. So it's less affected by this one outlier here. So the median in home prices is preferred because it doesn't get as messed up by that outlier that you see there. Where was I? Right. Also, the median does not use every data value. So that's sort of the strength and the weakness, right? You could say, well, I think it makes sense that you should use every data value in a calculation. Okay. But then you do that when you're doing the mean, but then you also get weird values because you're also including those outliers in your calculation. Whereas the median, you could argue that you're counting all the data values, but when you actually calculate it, you're not using every data value, which means that the outliers are always going to be on the end. The outliers are either going to be on the top side or the bottom side. By definition of an outlier, it can't really be in the middle, right? So that means you don't take the outliers into consideration really when you're using the median. So those are sort of that's why one of those is almost always a good measure, because if you have outliers, your mean may not be as useful to you, but your median's probably going to save you. If you have a situation where your median's, maybe not what you want to use, then see if the mean will get what you want. And almost always one of those two is going to be a good, appropriate tool to use. You're just going to have to figure out which one it is. Mid-range, pretty straightforward. Don't worry about that too much. And if there's any questions, make sure you throw them into chat so I can answer your questions. Yeah, in the homework, some of these books, they give complicated round-off rules. Just pay attention. Usually what I'm seeing is in the homework, it's telling you when it wants things rounded, it's telling you where to round it, right? So I've helped students with problems where it says round to the integer. I've helped students where it says round to the hundredths place or thousandths place or whatever. So just be careful, because remember, when you put something in the calculator and it says like 0.33, That's actually a little different than 1/3. So you'll have to round to the proper place. And like we said, when we're talking about measures of center, we are talking about numerical data. We are talking about quantitative data, because it doesn't make it, like, it's obvious that you wouldn't take the mean of eye color, right? It's obvious that you wouldn't take the median of the type of automobile that you own, or something like that. It doesn't make a lot of sense. But then when we have data that are numbers, a lot of times people will still try to treat them as numerical data even when they're not. For example, like what they give here, the zip codes. Would it do you any good to take the mean of zip codes? No. Would it do you any good to take the median telephone number of the class? No. That's not going to tell you anything. It's not going to help you, right? So keep that in mind when you're doing this. Always, before you perform a calculation on your data, just ask yourself, what type of data am I dealing with, and is it appropriate for me to use this tool that I'm dealing with? Let me remember this. Okay, so here's an example where you have to be careful. Sometimes this is another type of problem. Students get into, well, I've got two numbers, so I can just apply this tool to it. It happens a lot, because if you tell StatCrunch to calculate a statistical, something statistical for you, it will do it, as long as it's, not, obviously if you have eye colors and you tell it to take the mean, it's not going to come back with an answer. But if you give it numbers and say take the mean, it's going to give you back a value. So here's an example where we've got class size, okay? So it is well known, like all research has shown for decades, that smaller class sizes are generally more effective. California has a mean of 20.9 students per teacher, and Alaska has a mean of 16.8 students per teacher. This is probably very old data. I don't think those values are close to that. Also, kindergarten and first grade and stuff usually have lower class sizes, but California, I would bet, is well above that. But that's different. So then what some students would say is, oh, well, I want to come up with the mean for California and Alaska together. So they take the two measurements and they take the mean and say, okay, the mean class size for California and Alaska is 18.85, because I found the two means and then I took the mean of those means. Now, it doesn't work that way, right? Because California has 40 million people in it, and Alaska has what, a few million people in it. So actually, if you went like these values can't be combined because you're giving them equal weight. But California has a lot more people in it, with its like this carries a lot more weight. So what you'd have to do if you were going to calculate that mean, you'd need all the original data and recalculate it from there. So just always, that's why it's really important, not just that you go, oh, well, I can just tell StatCrunch to calculate a mean for me. You have to understand what is actually being done so that you don't end up doing something silly like this, right? Because I see a lot of weird stuff. Like, I see a lot of people in their projects do stuff that I never would have predicted, right? I mean, and I'm not trying to get on anyone's case, but they're thinking through it and they go, oh, well, I could use it in this way, right? I could use this tool, but they're actually doing something that completely doesn't make any sense, but they don't really understand the underlying statistics. They just know, well, every time I tell StatCrunch to find a mean, it gives me a number, so it must be working, right? Not necessarily. The number it gives you may not be useful. Just like when you take the mean of phone numbers, StatCrunch, if you put a bunch of phone numbers in here, you take out the dashes and parentheses and stuff, and you put phone numbers into StatCrunch, it will calculate the mean for you, but it will calculate it, it won't mean anything. Like, you'll think you got something meaningful, but it won't make sense. You will have a couple homework problems, so just follow along and do it in StatCrunch, where they give you frequencies like this. So instead of listing out all the data, they'll tell you the frequency values that you got. So this might look really scary. This might look really complicated. It's actually not, right? This is just the sum of the frequencies, and this on top is the sum of the frequencies multiplied by the data value. The videos will walk you through how to do these. So if you get confused, come see me, right? In the other class, I had one student get confused by it, and I helped her out, and then that made sense, but the rest of the students were kind of able to get it from the videos. So watch the videos, and you should be good. So you've got that. So you've got weighted means, calculating a mean from a frequency distribution. Those are just a couple examples of values that you'll have from in the homeworks, right? You'll have to do a few of those. See me if you're confused by those. Right, and just remember, once you get in here, so look for there's the little like blue with some white holes in it. On the homework, you can open your data set. Once you open the data set, it gives you the option to open it in StatCrunch, and then StatCrunch is going to create a lot of this stuff for you. So if you're ever confused on how to do something in StatCrunch, like this, I do this, right? If I haven't taught stats for like 6 months, or it was 6 months since I tried to do this one thing, and I'm like, where is it again in StatCrunch? I can't remember where this thing is. You just look up, you just go, depends on what you want, right? If you want a video, go into YouTube and just type StatCrunch correlation, or StatCrunch frequency distribution, or StatCrunch weighted, let's see, what was the problem called? Weighted mean, or something like that. Like whatever it is that you're looking at, and there will be a video there that shows you exactly how, like someone will have made a video that shows you exactly where to go in here, where to find the thing that you're looking for, and how to do it. Okay, and I'll share more of some of that along the way. But if you're ever stuck, like you're always welcome to come with me, and we'll take a look at it together. But if you don't want to wait till the weekend's over, you want to get your homework done, just look it up on YouTube. Like it's super fast, right? Like I say, I do that when I forget. Wait, is it under stats or is it under data? I can't remember. And then you just look it up and go, oh, that's right. That's what I'm supposed to do. Okay, so that can be pretty helpful in that case. So like I said, always calculate the mean, always calculate the median. Look at both of them. Are they close to each other? If they are, that means you have a data set that is, you never know till you have to look at other aspects of it that we'll be looking at. But if your mean and median are close together, then you probably have a data set that, it might be kind of a normal distribution. It might be sort of well-behaved. If your mean and median are far apart from each other, that might indicate that your data is a little bit skewed one direction or the other, or it might mean that you have one really big outlier out there that's sort of tipping everything one direction, but you're not really going to start getting a sense of what that data looks like until you look at the mean and the median and figure out what that's looking like, okay? Reminder, so I know it looks like this stuff is really far out, and you're like, man, it's the 11th, and I don't have to do, this stuff's not due till the 24th. Well, remember, the next chapter is due the 25th, and the chapter after that's due the 26th. The reason for this was I had accidentally originally had the chapter 4 dates wrong. I should have had chapter 3 due a little bit sooner, and then chapter 4 due like a week later, but I kind of feel bad since I already had this set as October 24th. If I bring it in closer, then some students will complain, oh, well, I thought I had more time to do chapter 3. So I'll give you the full time till October 24th, but just realize that next chapter is due the next day, and the next one's due the next day. So don't wait until it's almost the 24th to start doing chapter 3, or you're going to be in a panic zone, and then it's for a few days, and then your scores will be low because on a bunch of it you'll only get half credit because it'll be late. So do not wait on chapter 3. Okay, do not procrastinate on that. And and take the survey, please. Any of you, right? I'm guessing the 5 people in here are probably, for the most part, people who took the survey already. If you have not, please take it. The sooner we get those taken, the sooner I can release your data to you. And it's, I'll tell you, it's a lot easier to do your work for your project at the same time you're doing this stuff. So like, let's just say that I could release the data Wednesday, which is doubtful considering we have less than half of the class has taken it and hardly anyone showed up today. If you had your data, then at the same time you're learning about measures of central tendency, you could be getting your means and medians and all that kind of stuff ready for your questions. When we get here, you could be getting your standard deviations ready. It's just easier to do that as you're learning it. As it will be, you'll come back in a couple weeks from now, and then you'll do all that work. But you might have forgotten some of the details of mean and median and stuff like that. So it's just nicer when you can do the project work at the same time that you're learning the material, rather than going back and trying to remember it all. Okay, so please do that. If you haven't taken it, you're all in this together. You all need nearly everyone to take the data, right? We never get 100% of people, but it'd be nice if we could get like 98% of people to get that, so I can release the data, and then you can all have more time to work on your stuff, right? So, okay, thanks everybody. We'll end it there. As always, I will stick around in Zoom. Anyone who wants to have a conversation with me about anything class related, please come see me. Please come talk to me. And we can, I can help you with whatever it is you're confused about or you're nervous about or anything like that. Come talk with me. Otherwise, I will see you in a couple days. All right, thanks everybody.